Chang.
For zero order, it change instantaneously and first order and
你没有拿 IG 咩？
Okay, and
谁的 IG？
what is the
等你啊，等你拿钱啊。
what is the output response that we have learned for first order system last week? Peng Kui. What is the output response that we have learned? I think we only learned one last week. Only one, just one only. What is the type of the output response that we have learned for last week for this first order system? Step, okay, yeah, step response, step input, step response. Kenneth, what's the definition for? Hey, cannot look lah. Cannot look lah. What's the definition for rise time? Easy, right? Rise time. I didn't ask you time constant. Time constant, the value is even more specific. Rise time is quite
0 point.
So what's the definition for rise time?
Something 90%.
Give me a proper description about it. Rise time, so means the time taken for you to. You already said 90%, so how to put it in a proper sentence?
Respond 90%.
Time taken for you to achieve, to respond 90%, right, of the final output, okay? If let's say you are at the rise time, right, so what will be the value for your error fraction at that point?
0.
Okay, very good, not bad, you all remember, Alright, so, oh, never mind, I still have another one. Zhongzhe, what's the definition for time constant? Looking at it also need time to. Okay. Okay, by the way, RAM response, we have no question on this. Okay, so, but just to let you know, so RAM response meaning you can see the input and output. Looks something like this. Okay. Frequency response. Frequency is part of the important chapters. Okay, for this topic. So what we study here is actually the sinusoidal frequency. Okay, so you can see. Sinusoidal response. So if let's say sinusoidal input, how it should look like, you all should know, right? Sine. Okay, so you can see here x equals to a basically is the amplitude, right? Okay, sine omega t, right? Omega t. When it comes to omega t, I want to ask Wilbur. Pretty sure you took electrical machine last sem, so did you take? Yes, right. So do you still remember what's the formula for omega? Omega equals to 1/2. Two is not 1/2, it's 2. 2 what? Omega equals to 2 pi? Yes, 2 pi f. How could you all forget? Omega equals to 2 pi f. This one is not given in the exam. So if you see omega, you should have the memory. This is 2 pi f, right? Okay, so periodic signals are actually found in many applications. For example, vehicle suspension system or reciprocating terms, right? Okay, so let me see. That is not that one. Okay, so basically same like I mean the idea of this frequency response. I mean for the solution, right? When we study the step input and when we look at the solution, same thing. Transient response is something that we decay zero when time pass. Then you will only be left with this steady state response. Okay, so this is what is important for us. What remains here is what is important for us. So you don't have to bother about this transient response, right? So you can see here, we are interested in only the steady state response. Okay, so if let's say you were to rewrite this equation here, you can see that the amplitude, right? I mean the amplitude you can just rearrange it and equals to Ka and all these. Don't have to worry about it. If I ask you to calculate the amplitude or anything like phase shift and all these formula are being provided. You don't have to memorize it. Okay. So basically, your phase shift, your amplitude, basically is something that you can you can just derive from the solution, right? What else is important? Let me check first. Okay, just to introduce you some other terms. Okay, for example, this amplitude ratio here. Okay. Basically the ratio of output to input amplitude is what we call as amplitude ratio. Sometimes we may use other terms to call this magnitude ratio, but you should know they are the same thing, okay? Magnitude ratio or amplitude ratio. So what's the purpose of knowing this magnitude ratio? So I already put a small box up there, you all can read through, okay? So for you to understand what is it for, right? Okay, so magnitude ratio basically is something you can use to examine the amplitude response of a dynamic system. Okay, so the so on so off you can just read it on your own. I will leave it to you. So you can look at this graph here. Okay, so that's basically what's the frequency response of a first order system. If let's say you have the amplitude ratio being plotted against the frequency, right? I'm not sure you all still remember when we studied filter response, then we always talk about this attenuation of 3 dB, right? So you can look at this. This is where you have the cutoff frequency at this omega tau equals to 1. So there's a definition for that. I'm not sure you still remember or not. Basically, this means when the power cut in half or something like that, right? Okay, so remember, if let's say in the exam when you are asked to design the filter and you're not given any value of the attenuation, we just assume it's always negative 3 dB. Okay, I think we have agreed on that quite some time ago. I'm not sure you still remember or not, because that was like week 3 or 4 like that. Okay, so dynamic error. Okay, dynamic error is a very simple definition. Basically, when you have your amplitude ratio minus 1. Okay, this one is actually a measure of your system inability to reconstruct the amplitude. Right? So what kind of question that can come up from here? Usually for first order system frequency response, we will just give you a certain value, then we ask you to what will be the output. If I ask you what is the output, then you know you have the solution. You need to do something with the solution, right? The solution is basically y equals to something. You know that's the output, right? So usually the question is quite direct. Give you a certain value, okay, and then ask you to give the output. Then you can just slowly find out all these value and then just present your solution. Or the question also may ask what is the amplitude ratio. Then you can sub all the value in. So that's why I say this chapter is actually quite direct. So you just find the value of tau, you just find omega, and then the question also may ask find the phase shift, right? Find the phase shift. So it's quite direct. If let's say if we were to give you a less indirect question, maybe we will give you a certain value and tells you this is a dynamic error, then you can find the range of your tau, like maximum, what would be the maximum tau and something like that. Okay, later on you will see the question later. Alright, time delay is also quite a popular question, right? I have listed out two methods here for you, so I will guide you here now. What's the difference between these two? These two, no matter which method 1 or 2 you do, you should reach to the same final value. For example, if let's say the time delay you get from method 1 is 2 seconds, if you use method 2, you should be getting the same value as 2 seconds. Of course, in the exam, we don't expect you to use both. Okay, but I think it's actually a good opportunity here for you to check your answer. Yes, you can check your answer. If let's say you do method 1, you get 2. And then if let's say you have free time, you do method 2, you realize that you get 3. Then you know something is wrong with either one of them already. Okay, so for method 1, you can see the bracket here is what makes the difference between these two methods. Okay, this phase shift here, you actually will get from, for example, phase shift here is negative 10 inverse negative inverse tangent and then omega tau, right? If let's say you set your calculator in radian mode, you will get different value, isn't it? When you set your calculator in radian mode or degree mode, you will actually get a different value for a phase shift, right? So this is when you set your calculator in radian mode, so you get your phase shift in the radian form, and then divided by omega. Okay, the second method is where you set your calculator in degree mode, so you will get a value, or let's say for 90 degree or something like that. So you divide it by 360, then multiply with 1 over f. That's the difference between these two methods. So it's up to you which one you want to use. Is both of these is at the back of your question paper. Okay, but I think it will be good if you can just use either one of them to check your answer, to double check your answer. Okay. Alright. So after talking for so long, okay, so now it's time to do some hands-on. I think this subject you probably need more hands-on instead of me keep talking here. Okay, so look at this question. Okay, a temperature measuring system, you have a time constant of 2 seconds. Okay, if you want to measure a temperature of heating medium, this one change sinusoidally between 350 and 300. Okay, obviously this one is a sinusoidal input, so this one will be a frequency response. Okay, so with a periodic of 20 seconds, right? Sinusoidally change between 350 and 300. Typo here, not fine. It should be fine. Okay, find the maximum and minimum value of the temperature, right? Basically, this one means that based on the output, what will be the maximum and minimum. So first of all, you need to find what is the output solution. Okay, before you go and find what is the maximum, minimum, and then find the time lag. Okay, just now I've mentioned time lag is also means time delay, same meaning one. Alright, so the very first thing that you should do here, first part of the question is find the output first, because from this output you can actually observe what is the maximum or minimum. Actually, this one is the solution. This one is the output solution. The solution is there already, but I want you to take out your calculator to see whether you can get this output solution or not. Then later on, I want to ask Zhikang, okay, because Zhikang max is very good. So how to find the maximum and minimum value from this solution? Never mind. You all check whether you can get this output. Okay. First of all, if let's say this is exam, where do you get the output solution? Which one should be the formula? I look at the paper that I give you. You should be able to find the formula there. Take it out, because that one is for your convenience. You don't have to click here and there for the answer. Take out the paper that I gave you. Qi Yuan, I think we will keep for you, is it? Yeah, you have the file, right? Remember? I think you keep for someone else also. How nice, huh? Refer to the list that I gave you. It's easier for you to look at the. Yes, in home. Why you sit there quietly? What happened? You forgot to bring. Never mind, you can share with your friend. No, your friend also never bring. We're good for them. Okay, you can refer to the formula. I look at which one should be the one that you are using. So what is stated there in the list of formula? Zhijian, which one? Can you read the formula so that we know which one we are referring to? Frequency response. What's the formula? Y equals to carry over square root of 1 over 1 plus omega tau square sine omega t negative inverse tangent omega tau. Okay, I have high expectation that all of you will do well for this section because I provided the formula already. You don't have to memorize. Okay, can So this one is actually the output solution, the steady state response here. So you just have to figure out what is K, what is A, what is omega, what is tau, omega t, all this. Then you should be able to present your solution. Here, this one is the solution. I want to ask a question. Okay, never mind. You all leave this 325 alone first. This one is the steady state response, right? Because I have a very important question. This one, anyone want to volunteer? Amelia, do you want to volunteer?
Yes, if you want.
For the 325, I want to ask why out of nowhere there's a 325 there? What's that purpose? Why you want to get average out of nowhere? I know it's from the 350 and 300, but why do we have to add the 325 there? Yeah, why? What do you mean by average? Why do you need to outweigh add an average there? Never mind. You all figure out the output solution first, then slowly think about the 325. Okay, first of all of you here, you just need to focus on finding this one first. Because this one is a very simple one.
Wait, are you already doing